Welcome to The Explainer. Today, we're diving into a material that sounds like it's straight out of science fiction, something that seems to defy the very nature of liquid itself. We are talking about droplets that can roll, bounce, and survive in ways a normal drop of water just can't.
So let's kick things off with a little thought experiment. Just imagine for a second, what if a water droplet could wear a suit of armor? A flexible, protective shell. How would it behave? What could it even do?
Well, here's the thing. This isn't some sci-fi fantasy. It's a description of a very real object that is already starting to revolutionize microscale science, everything from tiny chemical reactors to a whole new kind of computing.
And this is the star of our show today, the liquid marble. The idea was first reported back in 2001 by scientists Ocelus and Curry, and it's a deceptively simple concept with some, wow, incredibly powerful implications. All right, let's get into it. So what's the big deal? I mean, what really separates a liquid marble from, a regular old drop of water? Well, as it turns out, the difference is pretty much night and day. I mean, just look at the comparison here. It's pretty striking, right? A normal droplet hits a surface and just splats. It's gone. But a liquid marble can actually bounce. And while a regular drop wets whatever it touches and leaves a trail, the liquid marble? Nope. It stays completely self-contained, rolling around like a tiny little ball bearing. And, maybe most importantly, that powder coating dramatically slows down evaporation. We're talking sometimes doubling the droplet's entire lifespan. Okay, so all the magic here is in that armor, that shell of microscopic particles. So how does a droplet get its coat in the first place? Let's break it down. The process is almost effortless. It's crazy. You just roll the droplet over a bed of hydrophobic powder, and the particles spontaneously, and I mean instantly, attach themselves to the liquid surface. This all happens because of physics. It's just a more stable state for the whole system. And in an instant, boom, you have a perfect encapsulation. And get this, the versatility here is just incredible. The shell can be made from a huge range of materials. Everything from natural powders like lycopodium spores to common polymers, all the way to high-tech stuff like carbon, metallic nanoparticles, or even those super light silicon aerogels. And each different powder gives the final marble a unique set of superpowers. So scientists aren't just making plain old simple marbles anymore. No way. They are engineering them with incredible new abilities. And they do it by choosing not just the liquid core, but also the armor very, very carefully. Here is a perfect example of a problem that was just begging for a solution. Liquid metals like Gallium are amazing for things like soft robotics, but they have this one fatal flaw. They oxidize in air almost instantly. They form this sticky skin that makes them practically useless for any kind of precise movement. So the solution? You guessed it. You turn it into a liquid metal marble. By coating the droplet with a mix of ferronickel and polyethylene particles, you solve all of those problems at once. All of a sudden, that sticky, unpredictable blob becomes a non-sticky, elastic sphere that bounces. And because of the iron content in the shell, it can now be precisely controlled with magnets. It's a total game changer. All right, so now we understand what they are and how they're made. Let's get to the really fun part, looking at the truly astonishing things they can do. This is where the concept really comes to life. First up, something you probably never, ever expected. These tiny spheres could actually become the building blocks of a new kind of computer, one that works without any traditional wires or circuits at all. Yeah, the concept is called collision-based computing. The idea is that the liquid marbles act as bits of information. Their presence or absence is a 1 or a 0. By precisely controlling their paths and then making them collide, you can create the fundamental logic gates, the ands and the nors, that power all of our electronics. The outcome of the collision is the result of the calculation. It's wild. Okay, beyond computing, liquid marbles are also being developed into these powerful new tools for cleaning up pollution. And we're talking specifically about oil spills. So instead of using the marble directly, scientists are using them as templates to create these tiny hollow microcapsules. The result is a material that actually outperforms the current industry standard, polypropylene, absorbing more oil per gram. And here's the best part, they can be made magnetic. So after they've soaked up the oil, cleanup is as simple as just using a magnet to pull them out. And the list of potential uses just keeps on growing. It basically turns each marble into its own little self-contained laboratory. Using magnetic fields, you can literally open the shell, add a new chemical, and then close it to trigger a reaction. They can transport delicate biological samples without contamination. They can act as smart sensors that just burst when they detect a specific chemical. They're even being used as tiny incubators for growing cells for medical research. It's amazing.
So after all that, what's the big picture? What should you really take away from all this? Let's just quickly summarize the key points that make this technology so revolutionary.
It really comes down to these 4 things: their incredible versatility in what they're made of, their ability to do complex tasks at a tiny, tiny scale, the precise control we can exert over them using things like magnets, and just the simple robustness that the shell provides. All these properties combine to make liquid marbles one of the most exciting new platforms in materials science today.
And this is the question that researchers are really asking now. What problems could we solve if our tiniest tools were smart, self-contained liquids? I mean, from targeted drug delivery inside the body to self-healing materials that literally bleed to repair damage. The future of this technology isn't just solid, but remarkably soft. And that's all for this